In this video, we will look at how to compare decimals to determine whether they are greater than or less than each other. But first, let's look at whole numbers and how we compare those. In the place value chart, if we looked at the number 4, 4 would be in the ones column. And we can represent the number 4 with 4 ones like this. It occupies one digit, and that is the number 4. Now let's look at the number 40. 40 has two digits represented by 4 tens and 0 ones. We can represent that by 4 sets of tens. That represents 40. It occupies two digits, and every digit to the left is 10 times as great as the one to the right. Therefore, the digits going left have a greater value than the digits to the right. The columns to the right we arrive at by dividing by 10. They are smaller numbers. So 40 and 4, if we compare the two, 40 is greater than 4. Now let's look at decimal numbers. If we wanted to look at 4 tenths, we would put a 4 in the tenths column. Again, that occupies one digit. One digit after the decimal is tenths. And we put a 0 in the ones column. To go from ones to tenths, it is dividing by 10, and the numbers get smaller. 4 tenths we can represent by 4 out of 10, represented here in this diagram. 4 strips out of 10 strips. But if we looked at 4 hundredths, 4 hundredths occupies two digits. We put a 4 in the hundredths column, 0 in the tenths, and a 0 in the ones. This can be represented by 4 out of 100. And in the diagram here, we see 4 boxes shaded out of 100. If we compare the two now side by side, 4 tenths is 0.4. It occupies one digit after the decimal. And 4 hundredths is 0.04. It has two digits. And we know that the value of the digits to the left are bigger than the value of the digits to the right. And so therefore 4 tenths we can represent here in this diagram, and 4 hundredths we represent here in this diagram. We can clearly see that the shaded amount of space in 4 tenths is bigger than the shaded amount of space in 4 hundredths. Therefore 4 tenths and 4 hundredths, when we compare them, 4 tenths is greater than 4 hundredths. Let's look at two more decimal numbers. 9 tenths we represent with 0.9. It occupies one digit after the decimal point. 9 hundredths is 0.09. Two digits are occupied when we talk about hundredths after the decimal point. Tenths is bigger than hundredths. The value of the number in the tenths column is bigger than the value of the number in the hundredths column. 9 tenths is bigger than 9 hundredths. We can see here 9 out of 10 shaded and 9 out of 100 shaded. We clearly can see the amount of shaded space is bigger in 9 tenths than it is in 9 hundredths. So therefore 9 tenths is greater than 9 hundredths. Now let's look at 5 hundredths, which we can represent by 0.05. It occupies two digits after the decimal. And 5 tenths is 0.5. 5 is in the tenths column. It has one digit after the decimal point. We know that hundredths is smaller than tenths. The digit in the hundredths column is smaller than the digit in the tenths column. This represents 5 tenths. This represents 5 hundredths. Again, we can see by looking at the shaded space that 5 hundredths is a smaller amount than 5 tenths. So therefore 5 hundredths is less than 5 tenths. Let's look at 5 thousandths. Thousandths is the third place after the decimal point. 5 thousandths, we write a 5 in the thousandths column, and we put zeros in the hundredths, tenths, and ones column. This is 0.005, which is 5 thousandths. It occupies 3 digits after the decimal point. Now 5 thousandths is represented here by 5 out of 1,000 blocks. We know that thousandths is smaller than hundredths because the thousandths column is to the right of the hundredths column. And we know that digits in columns to the right are smaller than digits in columns to the left. Thousandths is smaller than hundredths. If we look at 5 hundredths, we put a 5 in the hundredths column, 0 in the tenths, and a 0 in the ones. We see that that is two digits, 5 hundredths. We know that the hundredths column is smaller than tenths. Again, because hundredths is to the right, it makes it smaller. The tenths is to the left, and that makes it bigger. Now let's look at 5 thousandths. We place a 5 in the thousandths column, and a 0 in the hundredths, 0 in the tenths, and 0 in the ones. This contains 3 digits after the decimal point. This is represented in this diagram here, 5 out of 1,000 blocks. Thousandths is smaller than hundredths. This is because thousandths is to the right and hundredths to the left. Now let's look at 5 hundredths. 5 in the hundredths column, 0 in the tenths, 0 in the ones. We know that this is 2 digits after the decimal when we talk about hundredths, and is represented here in this diagram, 5 out of 100. Hundredths is smaller than tenths because hundredths is to the right, making it smaller. Tenths is to the left, which makes it bigger. Now let's look at 5 tenths. We put a 5 in the tenths column and 0 in the ones. It has 1 digit after the decimal, and we represent it in this diagram. We can see that 5 out of 10 strips is shaded, and we can see that that is a bigger amount of shaded space than the other diagrams. That's 5 out of 10. Tenths is smaller than ones, and that is because tenths is to the right of the ones column. The columns to the right, the digits have a value that is smaller than that to the left. Let's look at 5 tenths again. We put a 5 in the tenths column and a 0 in the ones column. We know that's 1 digit after the decimal anytime we talk about tenths. Represented here in this diagram, 5 out of 10. Look at the tenths column. Tenths is bigger than hundredths. Tenths is to the left of the hundredths, which makes it bigger. 5 out of 100, shown here in this diagram, you can see that the amount of space is smaller than 5 tenths. Now let's look at 5 hundredths. We write a 5 in the hundredths column and we put zeros in the tenths and the ones. It contains 2 digits after the decimal. This is 5 tenths, and this is the hundredths column. Hundredths is bigger than thousandths. 5 hundredths is represented here, 5 out of 100. This is thousandths, and we see 5 out of 1,000 is even smaller than 5 out of 100. Now let's compare a few decimal numbers and see if you can put all that into practice. 0.2 and 0.12, not 12. We call each digit 1 by 1 after the decimal point. 12 is a whole number, but 0.12 is a decimal value. So make sure you say each digit 1 by 1 when you have decimal values. 0.12. Is 0.2 less than or greater than 0.12? Well, let's put them in the place value chart and see. 0.2 we write as 0.2. 2 is in the tenths column. And 0.12 we write 0.12. We see that that 2 is in the hundredths column, the 1 is in the tenths column. This is 2 tenths, and this is 12 hundredths. There is 1 digit after the decimal in 2 tenths, and there's 2 digits after the decimal in 12 hundredths. In order to compare them properly, we have to have the same amount of digits in each one, and that will help us to determine whether the value is greater than or less than. So we're going to make the number of digits equal. And how do we do that? Well, 0.12 has 2 and 0.2 has 1 digit. Because 0.12 has 2, we need to make both of them have 2 digits. And we do that by writing a 0 in the hundredths column here. And we can rename that now with 2 digits as 20 hundredths. Now we can compare them. When we notice 0.20 and 0.12, we know that 0.20 is greater than 0.12. We look at the value after the decimal point, and we can see the digits 20, which remind us of 20. We can look at the number 0.12, and it reminds us of the number 12. And we know 20 is greater than 12, and so 0.20 is greater than 0.12. 20 hundredths is greater than 12 hundredths. There are more hundredths in 20 hundredths than there are in 12 hundredths. Therefore, 0.2 is greater than 0.12. On the number line, we can see 0.2 is here, and 0.12 is here. And so visually, any numbers that are to the right are bigger on the number line. So 0.2 is greater than 0.12. Let's look at the second question, 0.6 and 0.78. Again, we write them in the place value chart, 0.6 and 0.78. Again, we can see this is 6 tenths and this is 78 hundredths. But this has 1 digit and this has 2 digits. We need both of them to have 2 digits. We need to make the number of digits equal. And so we place a 0 in the hundreds column to make this 2 digits now. And we read that as 60 hundredths. And we have 78 hundredths. And so we know that 60 hundredths is less than 78 hundredths. 0.6 is less than 0.78. On the number line, here is 0.6. Here is 0.78. We can see on the number line that 0.6 is to the left, and therefore it makes it less. Now number 3, 0.9 and 0.053. Let's place them in the place value chart. And we read them as 9 tenths and 53 thousandths. We know that because the 3 is the last digit, and we look up and we see thousandths. But 0.9 has 1 digit after the decimal, and 0.053 has 3 digits. And so we always need the greatest number of digits in order to compare. So we make the number of digits equal. We place zeros in the hundredths and the thousandths column, and now that is 3 digits, and so we can rewrite these as 900 thousandths and 53 thousandths. Well, we know 900 thousandths sounds like a bigger number than 53 thousandths, and therefore 900 thousandths is greater than 53 thousandths, and so in our question 0.9 is greater than 0.053. On the number line, 0.9 is almost to the end where the 1 is, and 0.053 is all the way to the left, almost by the number 0. And so we can see that 0.9 is a lot bigger than 0.053. And now it's quiz time. Which one of these is the biggest? 0.5 or 0.05? And time's up. The answer is 0.5. That represents 5 tenths, whereas 0.05 represents 5 hundredths. Now question 2. Which is the biggest? Time's up, and the answer is 0.6. 0.15 is 15 hundredths. 0.6 is 6 tenths. We know 6 tenths we can convert to 60 hundredths, and therefore it makes that bigger. Now use the correct symbol for less than or greater than. 0.2 and 0.32. Time's up. 0.2 is less than 0.32. If we rewrote 0.2, we would have 0.20, which is 20 hundredths, compared to 32 hundredths, and 20 hundredths is less than 32 hundredths. Number 4, 0.15 and 0.7. Time's up. 0.15 is less than 0.7 because if we rewrote 0.7 as 0.70, 0.15, which is 15 hundredths, is less than 0.70, which is 70 hundredths. And the last question, 0.4 and 0.09. Time's up. 0.4 is greater than 0.09. Because if we rewrote 0.4, we would have 0.40, which is 40 hundredths, and that is bigger than or greater than 9 hundredths. And now you've solved the mystery of comparing decimal numbers. Great job.